Hello students, myself XI-Sci Gorane from RBNB College Srirampur. In last 6-7 lectures we have studied electromagnetic waves and communication system. About the electromagnetic wave, electromagnetic spectrum, different properties of that electromagnetic spectrum, and the communication system and important terms in the communication. Now today we see some numericals based on this chapter. First numerical is calculate frequency in megahertz of radio wave of wavelength (250 meter). And one main thing is speed of light for all EM waves is same as the speed of all EM waves is same as speed of light in vacuum, that is 3 into 10 raised to 8 meter per second. And here we have to find the frequency. Now we know frequency nu is velocity upon wavelength. Frequency nu is velocity upon wavelength. Wavelength is 250 meter. Velocity is 3 into 10 raised to 8 upon 250 meter. This is very simple calculation. We write this as, by adjusting the powers, 300 into 10 raised to 6 divided by 250, that is 30 upon 25, or this is 1.2. Simply this is 1.2 into 10 raised to 6, but unit of frequency we know it is hertz. But in our numerical it is given that we have to calculate the frequency in megahertz. 10 raised to hertz means 1 megahertz. So our answer is frequency is 1.2 megahertz. Such numericals carries 2 marks. Half mark for the correct formula, half mark for the substitution, and 1 mark for correct answer with unit. Then see next numerical. In EM wave, in electromagnetic wave, electric field oscillates sinusoidally that is sine wave. Sinusoidally at a frequency of 2 into 10 raised to 10 hertz. Frequency is 2 into 10 raised to 10 hertz. What is the wavelength of wave? Wavelength means we have to find the lambda of wave, and we know this speed of electromagnetic wave is same as speed of light, that is 3 into 10 raised to 8 meter per second. So given is frequency nu is given, that is 2 into 10 raised to 10 hertz. C is given 3 into 10 raised to 8 meter per second, and we have to find wavelength, and we know wavelength is velocity upon frequency. wavelength lambda is equal to velocity upon frequency. That is 3 into 10 raised to 8 divided by 2 into 10 raised to 10. That is 1.5. 3 upon 2 is 1.5. 10 raised to 8, when this is shifted to numerator, becomes 10 raised to minus 10. 10 raised to 8 minus 10 raised to minus 10. 10 raised to 8 minus 10 raised to minus 10, that is 10 raised to minus 2. And as this is the wavelength, a unit is meter. Very simple problem for the 2 marks. The wavelength of the wave is 1.5 into 10 raised to minus 2 meter. Such numericals carries 2 marks. Half formula, half mark for substitution, 1 mark for correct answer with unit. If the unit is wrong, half mark will be deducted. The next is the amplitude of magnetic field part of harmonic EM wave, magnetic field part of harmonic electromagnetic wave. In vacuum is magnetic field amplitude is denoted by B0, and that is 5 into 10 raised to minus 7 Tesla, or it is Weber per meter square, one and the same, Weber per meter square or Tesla. What is the amplitude of electric field part of wave? Amplitude of electric field part of wave. And this constant we know, velocity of speed of that electromagnetic wave is 3 into 10 raised to 8 meter per second. Now here this B0 is given. B0 is the amplitude of magnetic field part of the harmonic EM wave, 5 into 10 raised to minus 7 Weber per meter square. C is given, and we have to find amplitude of electric field part, that is we have to find E0, amplitude of the electric field part. We know the formula, C equal to electric field amplitude upon magnetic field amplitude. We know this formula. Therefore, this E0 is C into multiplied by B0. 3 into 10 raised to 8, substitute the values, multiplied by B0 part is 5 into 10 raised to minus 7, C multiplied by B0, that is 15, 3 into 5 is 15, into 10 raised to 8 minus 7, 10 raised to minus 1, that is 10. So this amplitude of electric field part is 150, and its unit is a volt per meter. Unit of that part is 150 volt per meter. So this is also one simple numerical which carries 2 marks. Then see the next, numerical. These numericals are very simple. A TV tower has height of 200 meter. Television tower has height of television tower has a height of 200 meter. Full stop. How much population? How much population is covered by TV transmission? Is covered by TV transmission if average population density around the tower is 1000 per kilometer square. 1000 per kilometer square. 1000 per kilometer square. Radius of Earth is given, that is 6.4 capital R, 6.4 into 10 raised to 6 meter. This is the radius of the Earth. Now here height of the television tower is given. So given H is 200 meter. Given data is height of the tower is 200 meter. Then population density is also given. This is H. Population density, suppose it is N, and this is 1000 per kilometer square area, km square. Now 1 km is, this is 1000 means 10 raised to 3. 1 km means 10 raised to 3 meter. 1 kilometer means 10 raised to 3 meter and its square. 1 kilometer means 10 raised to 3 meter and its square. So that is 10 raised to 3. 10 raised to 3 means this 1000. 10 raised divided by 10 raised to 6 meter square, or it is 3, when shifted to numerator it becomes minus 3 minus 6. 3 minus 6, 10 raised to minus 3 per meter square. Firstly we convert that population density per kilometer square to population density per meter square, that is 10 raised to minus 3 per meter square. Radius of Earth is given, that is 6.4 into 10 raised to 6 meter. We have to find the population covered. Population covered. Now this population covered is nothing but this population density into area. We find the population covered by using the formula population density into area. Firstly we find the area covered, and that area covered is pi d square, where d is the range. Area covered is pi d square, d is the range, and we know that d is square root of RH, twice RH, its square. Range we know it is square root of 2 RH. So this is 2 pi RH. This square is 2 RH. So this is 2 pi R into H. By squaring this we get 2 RH into pi, that is 2 pi RH. We simply substitute here values. 2 into 3.142, R is 6.4 into 10 raised to 6, and our H is 200, that is 200 meter. Now see here, this 200 means 2 into 10 raised to 2, and that 10 raised to 2 and this 10 raised to 6, that is 10 raised to 8, and here there is 2 into 2, 4 into 3.142 into 6.4 multiplied by 10 raised to 8. This 200 means 2 into 10 raised to 2. That 10 raised to 2 and 6, 10 raised to 8, and this 2 and 2, this is 4. 4 into 3.142 into 6.4 multiplied by 10 raised to 8. Now we solve this much part by using the logarithm, and then that answer will be multiplied by 10 raised to 8. So this is log 4. We solve this by using the logarithm, as there is a multiplication, plus log 3.142 plus log 6.4. Log 4 is 0.6021, characteristic is 0. Here also characteristic is 0. Log of this 3.142 is 0.4972. 4972 plus this is again 0 point, log of 6.4 is 0.8062. Log multiplication of addition of the log. By adding this log we get 1.9055, and we find the antilog of this. This antilog is 8044. As here there is one decimal point here, 80.44, but already there is 10 raised to 8. So 80.44 multiplied by 10 raised to 8, or we write it as 8.044 multiplied by 10 raised to 9 by adjusting the decimal points. This is the area covered. Now population covered is population density into area. Population density that is N is 10 raised to minus 3 per meter square. We have converted this into meter square, 10 raised to minus 3 per meter square. Multiplied by this area is 8.044 multiplied by 10 raised to 9. It means this is 8.044 multiplied by 10 raised to 9 minus 6, that is 10 raised to 6. Or we approximately write it as 8 into 10 raised to 6. This much population is covered. So this is our next answer. Then we see two more numericals based on the same chapter. Height of TV tower is 600 meter at a given place. calculate its coverage range. Calculate its coverage range. Range if radius of Earth is 6400 kilometer, 6400 kilometer. What should be height to get double coverage area? We have to find the height to get the double coverage area. See here, H is given, our given data is H is height of TV tower is 600 meter, then radius of Earth is 6400 kilometer, that is 6400 into 10 raised to 3 meter, or we also write it as 6.4 into 10 raised to 6 meter. H and R is given. We have to find its coverage range, that is D, and we know this D is square root of 2RH. This is range. Our first answer is range. D is square root of 2RH. 2 R is 6.4 into 10 raised to 6 into H is 600. H is 600. Now see here, this is 600 into 2, that is 1200 into 6.4, and this 10 raised to 6 outside the square root, it will be 10 raised to 3. Simply we have to solve this part. As this is square root, so 1/2 log of 1200 plus log of 6.4. And by solving this answer, we will multiply it by 10 raised to 3. Log 1200 is, see here, 1/2. Characteristic is 3. 3 point. That log is 0792. Plus, characteristic is here 0. Log of 64 is 0.8062. So this is 1/2. That much addition is 3.8854. Divide this by 2, we get 1.9427. And its antilog. Antilog of this number, that is 9427, is 8764. But as here there is 1 decimal point after the 2 digits, 87.64, but there is multiplied by 10 raised to 3. So this D is 87.64 into 10 raised to 3 meter. Coverage range is 87.64 into 10 raised to 3 meter, but this 10 raised to 3 meter means nothing but 1 kilometer. So this range is 87.64 kilometer. Now we have to find, next part is If radius of earth is like this, what should be the height to get the double coverage area? We have to find the new height, h dash. To get the double coverage area, it means new area a dash will be twice the original area. We have to find new area, and area is pi d square. So new area will be pi d dash square. D dash is our new range, twice pi d square. Initial range is d. So we get pi d dash square is equal to 2 pi d square, or d dash square is 2 d square. Pi get cancelled. We get d dash is equal to 2 d square, but we know h dash is d1 square upon 2r, d dash square upon 2r, h dash. H dash, that is the new height, that is d dash square upon 2r. We know this formula. D dash square is 2r h dash. So h dash is d dash square upon 2r, but d dash is 2d. D dash is 2d. So 2d square upon 2r. 2d square divided by 2r. This is h dash. H dash is 2d square upon 2r, but d square upon 2r is h. H dash is 2h. H dash is 2h. But before that, this h dash is 2h. We have to find d is equal to square root of 2rh, and that square root of 2rh is we know it is 87.64 meter. H dash is 2h. What is h? H is 600. So h dash is 2 into 600, that is 1200 meter. See again here, a dash is 2a, pi d dash square is 2 pi d square, d dash square is 2 d square. We get d dash square is equal to 2 into d square, but we know h dash is d dash square upon 2r, but this d dash square here, it is 2d square upon 2r. This part is nothing but h, and directly we get h dash as 2h, that is 2 into 600, 1200 meter. And then one last numerical on this chapter. A transmitting antenna at the top of tower has a height 32 meter. Height of the transmitting antenna is 32 meter, and that of receiving antenna is 50 meter. Height of the two antennas are given. What is the maximum distance between them? What is the maximum distance between them? We have to find the maximum distance between them. for satisfactory communication, in line of sight mode. Straight line mode, line of sight mode, in line of sight mode, and radius of earth is given r, radius of earth, that is 6.4 into 10 raised to 6 meter. Now here it is given that transmitting antenna height is 32 meter. We call it as HT. Transmitting antenna height 32 meter. Receiving antenna height, that is 50 meter. Radius of earth is given 6.4 into 10 raised to 6 meter. Here the range for the transmitting antenna, we call it as dt, and we know d is square root of 2rh, so it is square root of 2r. h means height of the transmitting antenna. Height of transmitting antenna is 32 meter. Height of receiving antenna is 50 meter. So range of transmitting antenna is 2rh, but here rh is height of that transmitting antenna. So this is square root of 2 into 6.4 into 10 raised to 6 into 32 into 32. See here, this 32 into 2, this is 64, square root of 64 into 6.4, and as this is 10 raised to 6, outside the square root, this will be 10 raised to 3. Simply solve 1/2 log of 64 plus log of 6.4, as there is a square root. So 1/2 log of 64 means 1 point, and that is 8062. Plus log 6.4 characteristic is 0 and its log is 8062. So this is equal to half of, addition of these two is 2.6124. Dividing it by 2, we get 1.3062, and its antilog of this number is 20.24, 2024. But as there is 20.24, but already there is 10 raised to 3. 10 raised to 3. So this is value of our dt. So our dt is 20.24 into 10 raised to 3 meter. 10 raised to 3 meter. 20.24 into 10 raised to 3 meter. Then we find dr, that is the range for receiving antenna. dr. This dr is also 2rh EHR. 2rhr 2 into 6.4 into 10 raised to 6 into 50. That is 50 into 2 is 100. 100 into this 6.4 is square root of 640. And this 10 raised to 6 outside the square root, this is 10 raised to 3. We see directly that 640 square root, and that is 25.30. into 10 raised to 3 meter into 10 raised to 3 meter, or this is nothing but 20240 meter, or this is dr is 25300 meter. By solving this is 10 raised to 3 meter, or this is 20240 meter, this is 25300 meter. What we have to find? Maximum distance between them for the satisfactory communication. That maximum distance is this range of transmitting antenna plus range of receiving antenna. So that maximum distance D is dt plus dr. dt plus dr. dt is 20240 meter plus this is 25300 meter. These two are in meter, and that is 45,540 meter. So this is our required answer, 45540 meter. So this is about the numericals in this electromagnetic waves and communication system. We stop here. Thank you.